everybody, this is Dr. Fontenot coming straight to you from my home kitchen. As you know, we've been asked to leave the building for the remaining duration of the quarter. So today I'm going to go ahead and execute our first lab experiment, which is dealing with grains and cereals. That is chapter 11 according to your syllabus. So first things first, I'm going to wash my hands. You'll see that my hair is up and I don't have my lab coat on because I forgot to get that out of my office. So I rescued an apron that I had from years past. So here we go, washing our hands. We've talked about this in our lab. We make sure we have plenty of warm water, free flowing. We use plenty of soap and we wash our hands for a good 20 to 30 seconds, making sure we get under our nails, around our cuticles, and up to our wrist. I'll add a little more warm water to really lather up my hands and get them nice and clean, and then I'll rinse really well. Turn off the faucet, grab a few clean paper towels, and wipe my hands dry. So if you've read the directions for this lab, one of the first things we have to do is measure our dry ingredients. And if you remember from the first couple of chapters, we talked about using the appropriate measuring tools to measure either our dry ingredients or our liquid. So in this case, I have a 1 cup dry measuring cup, and you'll see I've already measured out our ingredients for the first part of this lab, but I want to highlight which ingredients we're actually using. The ingredients are specifically for Lab A, or part of Lab A. I'll have the old-fashioned whole grain oats. We have quick cooking Quaker oats. And then I also have what we call instant oatmeal. And in our house, we happen to have brown sugar and maple flavored by Great Value, but instant oatmeal is the same across the board. So part of this lab experiment is actually learning how to use our scientific scales in our lab. So I brought one home for us to use for the rest of the quarter. And so I'd like to take a little bit of time to actually demonstrate how to properly measure ingredients and then using the scientific scale. So to begin, I will grab a paper plate. I will measure out 1 cup of the oats, making sure that the amount is level with the rim of the cup. I'll take my paper plate. The scale is already on. It's set at 0.0 grams. And it's been tarred. We tear the scale to make it sure it zeroes out. I'm going to place my paper plate, let it record the measurement, and while the paper plate is sitting on the scientific scale, I'm going to zero it out. And so now I just gently pour the 1 cup of measured oats onto the paper plate and allow the scale to do its job, and you can see it measured it out at 95 grams. So I've already taken time to measure all of the dry ingredients for this part of the lab, which happens to be the oatmeal. But the other thing we have to measure out is our water. So our labs require that we use what we call graduated cylinders. So once again, I brought these over to my house from our lab. And prior to the lab, I made sure that I measured out 1 cup of liquid. I actually used our liquid measuring cup, which is what we use to measure all our liquids. And then I transferred that amount of water into our graduated cylinders. Each one of these is 100 milliliters. And so I actually have 3 accounting for 240 milliliters, which is found in 1 cup of liquid cup. So that has all been taken care of. I want to call your attention when you're measuring water or any type of liquid, you have to read the measurement at the bottom of the meniscus. If it's milk, then you read above the meniscus line. So I just want to make sure I reference that. So we have everything measured out, and part of this lab requires us doing some simple culinary calculations. So to save a little time, I've already, as I said, measured these out. The lab says to measure the dry ingredients and the liquid ingredients out per the directions of the packages. So for one serving, I have a half cup of measured oats. And that actually translated into, and I would like you to write this down, for the rolled oats, 1/2 cup is 48.8 grams. So once again, the rolled oats, 1/2 cup is 48.8 grams, and then you add that to 1 cup or 240 milliliters of our liquid, in this case, water. And so I'll go ahead and write the rest of these measurements down. For the quick cooking Quaker oats, we're actually going to do one recipe variation using hot water, then one recipe variation using cold water. And both those measured amounts, which is a 1/2 cup, equal 48.7 grams to 240 milliliters of water. And then lastly, we need to prepare instant oatmeal. And of course, I just opened the package, and I'll go ahead and measure that water out when the time comes. And I'll add that, and I'm actually probably going to go ahead and pop it in the microwave and let it cook that way. So we're going to turn our attention to the stove, because we need to use the stovetop to cook the first 2 recipes. Now I'm going to call your attention to my stove. In either chapter 1 or chapter 2, the chapters spend a little bit of time talking about the different types of heat sources that are available to us. Well, one of the topics they talk about is induction. And I actually have an induction stove. And I have never cooked on one until we bought this house. I grew up pretty much cooking on gas. And so it's been really interesting trying to learn how to cook on this induction stove. First things we recognized or we learned is that our pots, which were typically magnolites, would not work on this stove. You need a specific type of metal to operate the stove. Otherwise, the burner will not turn on. So that's sort of a safety mechanism. All the heating is below the surface, so that keeps it safe, especially for little kids. It also makes it a little bit easier to clean. But the reality is you have to have special pots to cook on it, otherwise the stove will not work. I'm going to step back here for a bit and grab my measured water and put it into the pot. And let that come to a boil, and then I'm going to add my oats. Now remember, this is the rolled oats. And again, that measured amount of oats was 48.8 grams with 240 milliliters of water. So as soon as the water comes up to temp, which it shouldn't take long on the stove. That's another advantage of having an induction stove. Everything seems to come to a boil rather quickly. The problem is, for me, is I have a difficult time regulating the heat. Again, I'm accustomed to using gas, and I just find it's a little bit easier to regulate temperature using gas. But it'll come up to temperature rather quickly. And as soon as it does, I'll go ahead and add in this oatmeal. As it cooks, I want you to pay particular attention to the transformation that this oatmeal undergoes. It'll start as kind of a cloudy looking mess, and then as the oatmeal grain swells, it'll become a little bit thicker and thicker as the water evaporates and the grain or the granule absorbs more and more water. So as this is boiled, I want you to pay particular attention to the appearance of this rolled oat. You'll see that it's very, very flat, and it's there are very few broken kernels. When I compare this to the others that we're going to work with very soon, you'll quickly see a difference. So my water's boiling. I told you it wouldn't take you very long. I'm going to give it a stir. Now remember, if you've read the chapter, you shouldn't over stir any type of cereal, because that'll cause the granule to prematurely burst, and you'll get a very soggy mess. And that's the last thing we want with any type of cereal, but especially oatmeal. So right now the granules are pretty separate from each other, but as that granule swells, what is happening is the amylose and the amylopectin are becoming separated from the inside of the granule, and it's actually going to surround the outside of the granule, and that's what's gonna cause it to thicken. So in addition to that, we have the water starting to evaporate. So the combination of the granule swelling and the water penetrating in it and changing up the configuration of the molecule, of the starch molecule, will cause it to release some of the starch within the granule and become thicker and thicker as it cooks. So while this is doing its job, I just want to say I hope everybody is well. We really, really miss seeing all of you every single day. I feel in some ways that I'm a little bit disconnected from all of you, but hopefully this seeing me and knowing that you're seeing me, even though it's not real time, will make the situation a little bit better. I want you to know that all of the faculty are working very, very hard to make sure that we get you what you need this quarter without fail, and we're looking forward to starting the next academic year with a clean slate. So I want to encourage you that if you're struggling with accessing course material or learning how to navigate Moodle in sort of a different capacity than you have had to in the past, don't hesitate to reach out to us. We recognize that there are challenges out there, and we want to make sure that you're not stressed any more than you need to be at this particular point in time. So you'll notice that the granules are swelling and the water is becoming less and less, and that's for a couple of reasons. We have some evaporation going on, and of course the granules are absorbing the water. So we'll probably cook this just a little bit longer till we don't see any liquid and it's become a rather thick, solid mass. Once we do this, once we get it cooked, then we'll return it to the scale to measure the weight, and that's where these calculations come into play. And if you look in your lab manual, you'll see the formula has been provided to you, and it's just a matter of doing some simple division to get the final answer for the change in volume. So I'm not much of a fan of oatmeal, so I don't cook oatmeal on the stove. I don't even cook it in the microwave. So I'm gonna say this is done because I don't want to scorch it either. And using this stove, you can scorch things rather quickly. The pots that we use retain their heat really, really well, and so it becomes very difficult to keep things from burning if you're not being very vigilant and attentive to it. So I'm going to go ahead and say this is done and take it off the stove. I'm going to turn it off.
Just let it.
And I'm going to let it cool for a little bit. Okay, so now it's time to weigh the cooked mass. So before we weighed, I made sure that this glass container was tiered, and actually, and now the scale reads a 0.0 grams. So I'm going to ahead gently add the cooked amount of cereal, and again, this is the rolled oats, into the glass container. And you'll need to write this number down. So we now have 176.0 grams of cooked rolled cereal. So make sure you write that, document that amount down. I'm going to do the same just in case somebody loses their documentation. I'll have that for you. So the other thing that our lab experiment asks is that we monitor our cook time. So make sure when I start cooking this particular part of the experiment, you take a look at the timer on the computer and document from start to finish to estimate or document the prep time involved in this part of the experiment. All right, so I'm going to take this off the scale, put it off to the side. Looks like I made a little bit of a mess, which is not unusual for me in the kitchen. And I'm going to go ahead and wipe that clean, and we'll proceed. So the next part of our experiment is to work with